Well, thank you for joining us here today. I think we have a fantastic agenda of sessions that complements the theme of tall buildings or demanding buildings quite well, and from a technology perspective. And in this room is where the technology track is, the digital futures track, if you will. I think we have, as I say, great sessions. Each session is 3 presenters in conjunction, and we've grouped them with similarities. Either they may have worked on projects together, share a theme or a phase of construction, or so forth, and I think they'll complement each other quite nicely. At the end of the day, we have a panel discussion with the speakers in this track joining together to bounce ideas off each other and interact with the audience in a question and answer way. What I'd like to do is introduce this first session. We'll go in sequence. I'll sort of set the stage, if you will, looking at how technology is empowering things in a perspective from a software development point of view, if you will. Lars Hesselgren will then come up and share some thoughts from his experience and his work at PLP and so forth. And then Albert will come up and give us an engineer's perspective as well, and broader than engineering. So with that, I'm going to get started and move into some thoughts to get us moving. So I think the first, so who am I and why should you pay any attention to me? Well, I'm an architect. I practiced for about 12 years in a large firm in the States. Did mostly hospitals, large sports venues, and larger buildings there. And then was the technology director for that firm. And I've now been with Bentley for 15 years, first on the software side in the engineering, and now in the marketing and business planning side. So I'm trying to bring all of that experience together, as well as my participation in national and international standards groups. Bentley, as a company, our focus is on supporting all of infrastructure types. So we do buildings, but we also do roads and bridges and plants and offshore structures and everything. And tying the lessons from those different types of infrastructure to each other is a great advantage that we can bring, and I'll touch on that a little bit. I enjoyed the tableau of buildings at the bottom that the conference folks put together, and I thought it might be fun to look which ones used a significant percentage of Bentley software. And I was glad to see that it was more than less, which means that I'll have a job in the future. But the point is that it's interesting, and there's value in participating in those kinds of projects. As I say, we do software and solutions for all different types of infrastructure. And they inform each other quite well. The building industry, in some regards, is behind other industries in its adoption and implementation of technology for the benefit of the design process, the construction process, and the operational process. For example, in the plant industry, the process industry, the operational use of the information from design is paramount. That is a central principle to the design process. Because that's critical to the success of that infrastructure type. The building industry is only waking up to that potential in the past few years, and it's a very undistributed phenomenon. On the other side, there are less interesting, but utility systems, roadways, and so forth, that are in a constant state of construction and a constant state of rework and repair that have the iteration on the design information is much more involved and active than in a typical building project. So the design and construction almost never finishes. And so, of course, the information needs to be more live. And bringing that into the building industry is sort of what's happening and what our focus is. I'm not going to do a big commercial for Bentley, but I will say, if you're interested in who we are and what we do, look at our annual report. We're successful, we're growing. The only thing I'll point out is that our center of gravity, if you will, is in the top end of the market, the larger firms, larger projects, larger buildings, which is why we have such a synergy with the audience and the conference here. We sort of focus on our solutions in 3 sort of categories, if you will. We think about information modeling, the design, simulation, and analysis of infrastructure. Then how does that work in an integrated project through construction so that you have intelligent infrastructure when it's in operations. And if we look at that in a little bit more detail, one of the guiding thoughts is that the information needs to be mobile through all of those phases. So the concept of information mobility, allowing the right information to live through time, across disciplines, across phases, across different systems and formats of information, is very central to the way we approach our software development and so forth. And I think more importantly, is very important to you in practice, because the reality, and I've been speaking to some of our speakers in this track, every project is going to have a host of different software and technologies involved. That is the real world. And so you need to be able to bring the information that's helping you inform your decisions from one system to another, from one practice to another, from one format to another, and trust that that information is being accessed and moved predictably so that you can confidently make decisions on it and not worry about forcing different people to use. You can design it in Bentley software and then go analyze it in some other software or construct it using other software, and that's the real world, so that should be okay. So we focus on we have a very innovation-led culture at Bentley. I think one of the key innovations in relation to that information mobility is our iModel technology, which works with Bentley, Autodesk, Tekla, many different software vendors' formats to support information mobility and the exchange of information. More importantly, it also works with database systems and ODBC and other connectors so that it ties your model information into non-graphic or non-geometric systems as well. We also have a lot of software and experience in the operational side, asset health monitoring and predictive maintenance and so forth. Again, tying that operational phase use of information into leveraging the design information, even if the design information wasn't done in Bentley software. We focus a lot on some of the emerging technology formats that are becoming prevalent in this industry. So point clouds, we have point cloud integration with our design environment, streaming of point clouds so that you can manage multiple terabytes of point cloud information and interact with it on your laptop on the site in a very efficient way. We're also in strategic alliance with Trimble, developing some wonderful intelligent positioning to tie that scanning and sensing and layout tools of the real world with the digital virtual world that's in the software. We're focused on allowing all of that to happen in a mobile way. Use your iPad, use your iPhone, your Android device to interact with that information while you're out in the field, while you're on the job site. We have a very large investment in research. We typically are spending 20% of our revenues on R&D and acquisitions every year, and applying that research and making sure that research is productizable, if you will, so that we can integrate it into the solutions that we're providing. One very relevant area in the thinking of tall buildings is the generative optimization, looking at how can you use generative systems, genetic algorithms, multiple disciplinary optimization of systems for the very large and complex buildings of structure, energy, light, space, etc., and optimizing against multiple parameters at the same time. We also are doing a lot with virtual and augmented reality, looking at tools on mobile devices that allow you to see through the street and see what utilities are down there, or see through the walls and see your BIM model in place, in site, geolocated, so that you can actually peel away the wall, or like the guy on the right, see what's inside the wall without having to look at a screen, but actually see it as an overlay to your experience. So what does all this mean for the future? What are the buildings of the future, and when is the future? I kind of like this picture, seeing as we're in London. I think this is the 2020 plan for London. But I've always loved this quote, and I've used this quote for years because I believe it to fundamentally be true, that the future is already here, it's just not evenly distributed. So a lot of you are doing advanced things and applying technologies in innovative ways, but it's differently, and different areas and different technologies and different phases of the project in different parts of the world. So there's very few firms that are applying all of those innovations and all of the potential, and there are firms that are applying none. So the whole spectrum exists. And I think if you were going to focus on how could you apply these in practice, I think let's go back to those information modeling through integrated projects for intelligent infrastructure. We look at BIM and we think of it as a verb. It's building information modeling. It's not about the making of a model. The model is not the product. The model is a tool to help you make a building. And so we recognize that the information modeling is the important part, and you have information modeling for the building, for a system, for different asset type, for different asset types, and you have to integrate those with each other. And it's for the whole life cycle. So you have from all the way in early programming before you don't even know what the geometry layout is, through all your design phases and all your disciplines, into construction and then into operations. And you're going to have lots of different technology and participants along the way that need to work together. So the verb or the activity of information modeling is the key, not the production of a smart geometry model. Of course, it has to be multidisciplinary. You have all the different trades, all the different systems that have to integrate with each other. It has to be scalable. You have to handle size, complexity, integration of systems, integration of information types in that scale. You have to be able to do, we have this concept of hypermodeling. You want to use that information in a 3D context. You want to link to videos, spec sheets, drawings, reports, data, web pages, live webcams, machine reports and information streams in that 3D model, not just make drawings from it. You want to bring the other types of interaction that you have with it, whether it's point cloud sensor and scanner input, parametric systems and input, and presentation materials from that, and tie it into the same environment that you're making your design decisions within. You need to simulate, understanding all of the different systems and constraints and drivers for your decisions, whether they're the environment, safety, performance, operations, program, system parameters, whatever. Understanding that, visualizing that, understanding how that will apply to your design and construction process, but also to the operations phase. Understanding how to optimize. Now, optimize is always a tricky word. And any engineer will tell you there is an optimal solution to a problem. Any architect will tell you there is no single optimal solution. There are multiple. And that's maybe the biggest rub between architects and engineers over the decades. But the point is, you are doing a simulation of a system or of your building so that you can analyze your design, make informed decisions about what you want to do about it, so that you can come up with the optimal solution for your particular needs. Now, your needs will be a set of needs. So you're going to be balancing aesthetics versus cost, or program versus time, or an engineering constraint versus an engineering constraint in another discipline. So understanding how those work together and being able to look at a solution set of optimizations rather than a single one is a key driver. And I think the new technologies of cloud services and distributed massive parallel computing are really starting to enable that optimization process to incorporate multiple different inputs, optimize against each other, and provide solution set answers. And we have some interesting developments coming in that area. Looking at when you have that understanding from your simulation, you want to be able to visualize the answers in thematic ways. You want to be able to apply your parameters to the model and have it present color coding or animation or others that present the answer to the simulation without you having to make another static version of the model or drawing to do that. So on the fly, just quick color swapping and so forth. Integrate the point cloud and sensor data with that simulation so you can understand the current reality and the predicted reality. Great examples in the construction space where there are folks that they have laser scanners installed on site and they're running a scan at least once a day, storing all of those clouds and seeing construction progression through differencing of the point clouds. Tying that into the model of what's supposed to be built next week with what was built last week versus the difference to what was built the week before allows you to get a continuum between the virtual and the physical that is pretty exciting and interesting. Class resolution, being aware of where you are in the location as well, and location awareness not just to the end result, but to the materials and the systems as they're being fabricated and shipped and delivered as well. On the integrated projects front, tying that into the whole phase. So you're going to have drawings and data and models and systems that a lot of people are interacting with. They may be geographically dispersed around the world, and they're accessing that information to do different things with it. If we have an information model of a building, any discipline or even different people within any discipline are accessing and interacting with that model to do specific tasks. They're analyzing a structural load, or they're establishing the electrical requirements for a piece of equipment or whatever. And not everybody needs all the information all the time. So to be able to filter and aggregate information appropriate to the use that you're engaged in at that moment, and dealing with that in different systems and locations and accessing it through different devices. And then maybe one that's often forgotten is allowing that interaction and accountability for that information to persist over time. Some of these projects, and especially when you're dealing with operations, you could be talking about 30, 50-year life cycles of that information that you're modeling. And to understand that you're going to be able to predictively access and correctly connect to that information throughout that span of time puts a whole nother burden of standards and control into the process. We have a technology I mentioned before, iModels, that are particularly focused at that. They are neutral. It's a standard we've offered to the industry. It allows the information to be self-describing so that you can open an iModel in a Bentley tool or in a competitor's tool or in Excel or other link to it with a database connection, whatever, so that it has that self-describing capability. But it also has provenance. It knows where it came from, when it came from, who has done what to it over time, and all of that is independent and travels with the file. We also have a new technology just launching now, which is dynamic rights management. You can actually set permissions on the file that travel with it. So you can kill files remotely, you can update them, the file can check if it's up to date, has the information changed since this was published, so that you're confident that it's moving through your system and your processes correctly. Of course, mobile applications and devices are increasingly entering into the workflows and supporting those, but also the scanning and layout devices of understanding the point cloud of what's there, but also taking your model and the laser layout and positioning devices to instruct construction people where to place something and where to install things on site with a laser actually drawing it on the field. On the operational side, and I'm not going to touch on this one too much, we borrow from the ARC Advisory Board. They have a great white paper about asset lifecycle information management. I think it's a great principle. Basically, you have your project information management about who is doing what and when and what decisions were made and what's the process of the project. You have all the information that is cycling about the asset itself, the description of the physical things and the properties of them. And then you have portfolios of assets and properties and information about the, if you will, in this case, the real estate. All of those together are interacting with each other as part of your asset lifecycle information management. So here in London, I'll just close with this. We every year have an awards program, the Year in Infrastructure, where our users submit projects of note that they would like to highlight. Last year at our awards ceremony in Amsterdam, in the building area, it was interesting that the winner for the Innovation in Buildings category was the new King's Cross Station redevelopment from John McAslan and Partners, which is here in London. And in the construction category, lo and behold, another one here in London, Taylor Woodrow Bam Nuttall with the Victoria Station construction. Lo and behold, in our generative design category, Robin Partington Architects with the Park House, and Robin is going to be speaking on this agenda, and we'll show more on this project as well. And then the last one, Innovation in Government, was the Crossrail project here in London. So we didn't cook the books with the jury. Bentley doesn't even vote on these, but it was funny that this year in those 4 awards of our 13 or 17 categories actually, 4 of them were here in London. The last thing I'll point out, as we were coming here, and we're actually hosting a conference here later this year on the wall over there, and here we highlighted projects in London. We have an awful lot of buildings and other projects in London that are done by our users and software, and we thought that would be nice to share with you. Lastly, an invitation. In October, this year's Year in Infrastructure Conference will be held here in London at the, I think it's at the Hilton London Metropole Hotel. We will have the chairman of the Olympic Delivery Authority and the CEO of Crossrail as keynote speakers, as well as this year's finalist presentations. I'd encourage you to join us for that.